In this video, we'll be looking into NECO 2025 Chemistry Practical Preparation. So this is the Part B video. So I've made video for the Part A, whereby I've explained a lot of things in the Part A. So if you need the Part A video, just comment Part A under the comment section, and I will send you the link immediately. So this is my powerful predicted question for NECO 2025 Chemistry Practical Titration aspect, which I promised you at the end of my video in the Part A that my Part B video is going to contain my powerful predicted question for you to study it as a guide for you. So now this is the question I'll be solving right now. So just look at the question, read the question through, then let's start the solution immediately. So this is the question, as you can see it in front of you right now. Now let's go to the solution immediately. So now I'll be solving it here. As you can see, I'll be solving it here. Now, looking at the question now. So the question says that A is a solution containing HNO3, which is 0.1 mole per watt per dm cube. Again, it says that A is a 0.1 mole per dm cube HNO3. Okay. So, and then B is what? B is a solution containing 8 grams of a mixture of Na2CO3 and then NaNO3. So you can read the rest. So now let's go to the main question, which is what? Question A says that we should calculate the average volume of acid used, whereby we have done that here. As you can see it here, the average volume of acid used is here. I've done that in my part A, which is what? 26.10 cm cube. So the B part now says that from the result and the information provided, then we are asked to calculate A, the concentration of Na2CO3 in mole per watt per dm cube. So now let's work that. So let me write the 1B here. Says that from your results and information provided, calculate the concentration of what? Of Na2CO3 in mole per dm cube. So how are we going to give out that? So for we to look for concentration of what? Of B, that's Na2CO3 in mole per watt per dm cube. So what are we going to do? What are we going to do that because of these parameters we have? Okay, let me list out all these parameters we have out first. So we have the Ca, that's the concentration of the acid in mole per dm cube, that is 0.1 mole per dm cube. So we don't know Cb. I want to list all the parameters. We have the mixture, the concentration in gram per dm cube of the mixture of Na2CO3 and then NaNO3. So let me leave this first. Okay, let me write it here. So con in gram per dm cube of what? Of mixture. So of the mixture, and that is what? 8 gram per dm cube. Okay, 8 gram per dm cube. So then say put A into the burette and titrate to be okay. So here now 25 cm cube. Here now I have it as the what? I have it as the volume of the base. So VB is 25.00 cm cube. And for my VA, so for my VA is here. As you can see it here, the VA is 26.10 cm cube. As you can see it in that place. So my VA is 26.10 cm cube. Okay, what again? So from the result again, what again? That is all. So that's all. Nothing again from this particular question. All right. Now for my NA and NB, I think let me check the equation of the reaction. From here, equation of the reaction, I think is here. So as you can see it, my Na is 1, my Na is 2, and my NB is 1. Okay. All right. So my Na and my NB will be what? 1, 1. So my Na will be 2, whereby my NB will be 1, according to what we see here. Na is Na is 2, whereby NB is what? Is 1. Okay, Na is 2 and then NB is 1. All right. So after having this, that is all. So that is all we are given. So now going to the figure I question now. The I says that concentration of B that is Na to CO3, right, in mole per dm cube. So that is going to be, what formula can we use? Remember that we have just two formulas to solve this, exactly two formulas. So the one we are going to use here is just the CAVA over CBVB equals to Na over NB. That's the only thing we can use here. So that will now be CAVA all over CBVB equals to what? Na all over NB. So we are looking for CB, right? So let me make my CB the subject of formula. So my CB will be equals to what? That will be CAVANB all over what? VB NA. All right. Yeah. So, and if I should substitute this value inside that, then that will give me 0.1 times V is what? 26.10 times NB is what? 1 all over my VB. My VB is 25 times NA is 2. So if I should do that together, let me press the calculator. That will be 0.1 times 26.10 times 1. So equal to, and that will be 2.61 over 50, and that gives me over 50. 2.61 over 50, and that gives me 0.0522. 0.0522. So it's 0.0522. So my CB will be 0.0522 molarity, or you call it mole per dm cube, anyone. 0.0522 mole per dm cube. Always put this in three significant figure. Yeah, always put your concentration in three significant figure. It's very good. So I'm done with the I. Now moving to the II now. Moving to the II. So for the II, the question says that I should calculate, as you can see it says I should calculate what? The II. I should calculate the mass concentration of Na to CO3 in gram per dm cube. So the formula to use in that place is concentration of B in mole per dm cube is equals to concentration of B in gram per dm cube all over what? Molar mass. Molar mass. And as you can see, if I am looking for the concentration of B in gram per dm cube according to the question, mass concentration of Na to CO3 in gram per dm cube. So let me cross multiply. So that will now be concentration of B in gram per dm cube will be equals to, if you cross multiply, that will be concentration of B in mole per dm cube times what? Times molar mass. Times molar mass. So what is the molar mass of Na to CO3? Let me check here. I think I've done that in my part A. So molar mass of Na to CO3, that is okay, that is 106 gram. So that is 106 gram per mole. So 106 gram per mole. So then let me just write the 106 here. So that will be equals to concentration of B mole per dm cube is here. That's the CB, and that is 0.0522. So it's 0.0522 times 106, and that gives me, let me press it here, 0.0522 times what? Times 106, and that gives me 5.5332. So that will be 5.53. So that is 5.53 gram per dm cube. Okay, so I'm done with the B part. Now moving to the C part now. Now the C part says that I should calculate the mass of NaNO3. I mean the III rather. The III means I should calculate the mass of NaNO3 in the mixture. So calculating that, then that will be the mass of NaNO3 in the mixture will be III will be, this 8 gram per dm cube contains both mixture of this and this. So I have known the concentration in gram per dm cube of Na to CO3, which is what? Which is 5.5332. That's 5.53. So then total is 8. What would I do? I'll just subtract. So for here now, the mass of NaNO3 in gram per dm cube. So we just be the total mass minus the mass of Na2CO3, mass of Na2CO3. Hope you get what I'm saying. So that will now be the total mass is what? 8. So 8.00 gram per dm cube minus what like that? That will be minus 5.53. Okay. So that will be minus 5.53 gram per dm cube. So if I just subtract that, that will be okay. 8 minus 5.5, 8 minus what? 5.53, and that gives me 2.47. So the answer for this one is 2.47 gram per dm cube. So I am done with the III. Now for the IV. The IV here says that you calculate the what? The percentage purity of Na2CO3 in the mixture. So formula to calculate percentage purity, and that is let me give that IV. So percentage purity, the formula is what? Pure, I mean mass of the pure substance, mass of pure substance over mass or total mass of the mixture, total mass of the mixture times 100%, times 100%. If you like, I can put over 1. Hope you can see this. So mass of pure substance over total mass of total mass of the mixture times 100%. So from here now, percentage purity because the mass of pure substance is what? The pure substance is the Na2CO3. I've explained which one, why is it pure, which one is pure on my first video. So the pure one is Na2CO3. So the mass of Na2CO3 in gram per dm cube is 5.53. So 5.53 all over what? Okay, let me put my gram per dm cube. All over total mass is what? 8. Total mass of the Na2CO3 with NaNO3 is what? 8.0 gram per dm cube. So 8.00 gram per dm cube multiplied by what? 100% over 1. So if this cancel this, then what am I left with? I'm left with 5.53 divided by what? Divided by 8.00 times 100, and that gives me 69.125. So let me just leave it at 69 point, let me leave it at 1%. So the percentage purity is what? 69.1%. So that's for the IV. Now for the V now says that you should calculate the what? The percentage impurity of NaNO3 in the mixture. Okay, so for the V now, to total, if the total is 8, you already have the pure. Sorry, if yes, total is 8, you have the pure as what? 5.53. Yeah, as you can see it. So the impure will still go in the same way. It will be percentage of the impure. Let me work it here. Percentage of impure or impurity, anyone, equals to the mass of the impure substance, all over all over total mass of the mixture, total mass of mixture times 100%. You can put over 1 if you wish. So the mass of the impure, we have calculated it somewhere here. Let me check. That is what? 2.47 gram per dm, as you can see it. That's the NaNO3. NaNO3 is the impurity there. So that will now be 2.47 gram per dm cube over total mass is what? 8.00 gram per dm cube times 100% over 1. This also cancel this. So then I have it as 2.47 divided by what? Divided by 8.00, so times 100%, and that is what? 30.87. So let me approximate it to 30 point what? 30.9. So that will be 30.9%. So that's it. So we have done that. Another alternative you can use to do this v of question v is that, let me another method, alternative. So for this is that, since you have the total as 8, you already know your pure should be what? 69.1. It's not 69.1%. And you know that percentage means 100. You have pure should be 69.1. So what will you do? You will just subtract 69.1 from 100. Then the remaining one will be what? Your impure. You understand? So since percentage is a percentage means what? 100. So you will just say what? So that will be percentage of impure or impure substance or impurity, be just equal to 100% minus 69. 69 is the percentage of the purity, right? It's 9.1%. So if you subtract 100 from 69.1, then that will be what? 100 minus 69.1, and that will be 30.9. So 30.9%. So you can do it this way or you do it this way, you get the same answer. You understand? So these are the predicted question I have for you concerning this titration aspect. Please do well to watch this the part A video, and also share this part B video, and I wish you best of luck in your exam. Working on the qualitative analysis after this video. So if you need the qualitative analysis video, do well to comment qualitative analysis under the comment section. Then I will send you the link immediately. Bye.